AI engineers are being offered salaries that reach $210,000 per year in 2026. That is the headline number. That is what grabs attention. But as always, the real question is not how high the top goes. The real question is how wide the base is, how competitive the entry level has become, and how sustainable those salaries actually are over time. This is the full breakdown. Average salary levels. Entry versus mid versus senior. At the entry level, most AI roles do not start anywhere near 200,000. In 2026, junior machine learning engineers and AI developers typically land between $80,000 and $110,000 per year in the United States. That assumes a strong technical foundation. It assumes internships, research exposure, or serious project work. Without that, the range drops quickly. Many entry candidates underestimate how much production readiness matters. Mid-level AI engineers with 3 to 5 years of experience usually move into the 120,000 to 160,000 range. At this stage, impact matters more than credentials. You are not just training models, you are deploying them, you are maintaining them. You are working with data pipelines, monitoring performance drift, optimizing inference costs, and collaborating with backend and infrastructure teams. The value increases because the responsibility increases. Senior AI engineers and specialized machine learning experts can cross the 180,000 mark. In top companies, total compensation can exceed 200,000, sometimes reaching 210 or more. But those are not average outcomes. Those are high-performance brackets inside companies that depend heavily on AI systems for revenue, automation, or product differentiation. Market demand. Demand for AI talent remains real in 2026. Companies across finance, healthcare, cybersecurity, logistics, manufacturing, and SaaS are integrating AI systems into core operations. Predictive analytics, recommendation engines, fraud detection, optimization systems, and generative interfaces are no longer experimental add-ons. They are infrastructure. However, the hiring environment has matured. It is no longer the early hype cycle where any AI label commanded a premium. Employers are more selective. They want engineers who can ship, monitor, and improve systems at scale. They want engineers who understand latency, compute cost, data quality, and business metrics. The number of applicants has increased dramatically. Many software developers are pivoting into AI. Boot camps promise rapid transitions. Online certifications are everywhere. The result is a saturated junior pipeline. Demand is strong, but filtering is stronger. Competition level. AI is one of the most competitive tech fields in 2026, not because there are no jobs, but because the skill threshold is high. Real AI engineering requires mathematics, statistics, data engineering, system design, and domain understanding. It requires comfort with ambiguity. It requires debugging complex behavior under imperfect data. Companies are no longer impressed by model demos alone. They want measurable improvements. They want reduced error rates. They want cost-efficient scaling. They want systems that survive production environments. This means the path into AI is not casual. It is technical. It is layered. It rewards depth, not surface familiarity with tools. Junior reality. At the junior level, expectations are often misunderstood. Many candidates assume that learning a few frameworks is enough. In practice, companies want proof of applied work. That means deployed models. That means real evaluation metrics. That means understanding trade-offs between accuracy and speed. Entry salaries can still be strong. $80,000 to $100,000 is solid compensation. But reaching the 150-plus range requires years of accumulated execution. It requires demonstrating that your work improves business outcomes, not just model performance. Long-term outlook. AI as a discipline is not temporary. Automation, predictive systems, and generative architectures are now embedded in enterprise strategy. Over the next 5 years, AI roles are expected to remain central to digital transformation. However, the market will continue separating generalists from specialists. Engineers who understand distributed systems, scalable infrastructure, model optimization, data governance, and cost control will command premium salaries. Engineers who rely only on high-level libraries without understanding underlying mechanics will struggle to differentiate. Positioning strategy. If your goal is high AI compensation, focus on foundations. Strengthen your math and statistics. Understand gradient behavior. Understand data leakage. understand bias and evaluation frameworks, learn how to move from notebook experiments to production pipelines with monitoring and retraining loops, develop the ability to explain technical trade-offs in business terms. AI engineers who can connect model output to revenue, risk reduction, or efficiency gains become significantly more valuable. AI rewards builders. It rewards system thinkers. It rewards engineers who reduce uncertainty inside organizations, risk and resilience. There is volatility in AI hiring cycles. Venture funding shifts. Corporate budgets tighten. Research-heavy teams may contract during downturns. But applied AI tied to operational efficiency and revenue generation tends to remain resilient. The most stable roles are those embedded inside core business workflows. If your AI work directly influences customer experience, fraud prevention, cost optimization, or automation savings, your position becomes defensible. Final verdict. AI engineering in 2026 can absolutely reach $200,000 and beyond. But that outcome belongs to the top tier of disciplined engineers who combine theory, implementation, and business impact. The median path is strong but competitive. Entry is demanding. Growth is skill-based. And long-term success depends on depth, consistency, and measurable results. The salary potential is real. The competition is real. The opportunity is real. The difference is execution.